Hi guys, this is the video for lesson 6.3, the notes. So we're going to learn about using trig to find missing angles. Very exciting. Okay, so first thing we're going to start out with a question. How would you solve this equation for theta? How to solve for theta? So if I'm solving, that means I'm trying to get theta by itself. In order to get theta by itself, I need to get rid of sine somehow. Sine is there and it's kind of annoying. So really our question is, how do we get rid of sine? And when we're solving and we're trying to get rid of something, we're trying to undo that operation or cancel it out. So we want to know what undoes or cancels sine. So what undoes or cancels sine? And the idea here is like subtraction cancels addition or subtraction undoes addition. They're opposites. Division cancels out multiplication or undoes multiplication. They're opposites. So what is the opposite of sine that's going to undo it or cancel it out? Okay, so it turns out there are opposites and they are called inverses. So sine has an inverse, cosine has an inverse, and tangent has an inverse. And the inverse of sine is going to cancel it out. The inverse of cosine will cancel cosine. The inverse of tangent will cancel tangent. The symbol for these is similar. It looks like this. So the symbol for inverse sine is sin, just like sine, and then we put a little -1 up top. That's called a superscript if it's a little number above it. It looks kind of like an exponent, but it's not an exponent. It's a superscript that indicates inverse. And then we're going to leave a little space because we'll see that when we do inverse sine, we're going to put something inside of it. Okay, so that's what inverse sine looks like. An inverse sine cancels out sine. Okay, not surprising, inverse cosine and inverse tangent look similar. So inverse cosine is the cosine symbol with the little -1 to indicate that it's an inverse, and it cancels out cosine. And inverse tangent is the same, so tan and then -1 for inverse, and then our space for stuff we're going to put in there, and this cancels out tangent. So just like subtraction cancels addition, division cancels multiplication, we now have a tool to cancel out each of our trig operations. All right, so I'm guessing this seems a little weird so far, so we just need to see how this is going to work in an example, and I think it will come together. So let's look at an example. We want to solve for theta in this triangle. Our process for this is going to be really similar to the process we used for finding missing sides. We want to first figure out what sides we have. Do we have opposite and adjacent, opposite and hypotenuse? So we're going to figure out which sides we have. We're going to use that to figure out which trig ratio we want to use, sine, cosine, or tangent. Sorry, I have the hiccups. And once we figure out what trig ratio we want to use, we're going to write an equation with that trig ratio, and then we're going to solve it. And when we solve, that's when the inverses are going to come in. So let's start this and just see how it plays out. So I'm going to start by labeling my triangle for theta. I start with my hypotenuse, which is across from the 90, so 7 is my hypotenuse. Okay, then I go across the triangle from theta for the opposite side. So 4 is the opposite of theta. And that leaves this blank side to be adjacent. We don't even really need to label that side. Actually, I'm going to erase that. Oh no. Okay. So what we have is the hypotenuse, 7, and the opposite side, 4. So we have opposite and hypotenuse. Okay, now we want to ask ourselves which trig ratio involves opposite and hypotenuse. If you need to, you can keep writing SOHCAHTOA, write it as much as you need to. So I'm looking for which of these trig ratios, sine, cosine, or tangent, involves opposite and hypotenuse. And we can see pretty clearly it's sine. So we're going to use sine theta is equal to the opposite side divided by the hypotenuse. This is what we're going to use to write our equation. Okay, so let's come up here to step 3 where we actually write the equation. So we're using sine, so I'm going to put sine here. We don't know the angle. The angle is our unknown, so theta stays theta. It's a variable. Sine of theta equals, and then for this triangle, opposite is 4 over the hypotenuse, which is 7. So sine theta is 4 over 7. Okay, we're now trying to solve this equation for theta. We need to get theta by itself. That means we need to get rid of this sine. We have to cancel that out. So this is where the inverse comes in, because inverse sine is what cancels sine. So we're going to make a note to ourselves that we're going to cancel this using the inverse. Okay, so here's what that's going to look like. I'm going to do the inverse to both sides. So I'm sort of going to wrap sine inverse around everything on the left. And then if I do that to the left, I also need to do it to the right. So I'm going to wrap a sine inverse around the right. And here's what that looks like. So I've got sine inverse. And then inside the sine inverse, I have what's on the left side of my equation. So sine theta is inside there. Okay. So I've just applied sine inverse to the left side of my equation. Since I applied it to the left side, I also need to apply it to the right side. So I'm also going to do sine inverse of, and then the right side of my equation was 4 over 7. Okay, so that looks kind of crazy, but what's great about this is that sine inverse and sine cancel each other out. That's why we did this. These cancel. So I get to just cross those off, and all we're left with on the left side is theta. So we got theta by itself, which is awesome. That's what we wanted to do. So theta is equal to this stuff on the right. So theta equals sine inverse of 4 over 7. And we would like to turn that into a number. To do that, we're going to need to use our calculators. And it's a little bit of a process. So the first thing we're going to do in our calculator is turn 4 over 7 into a decimal. I have to write really small here. Okay, so we make that a decimal. I'm gonna blow up my calculator here a little bit. So I have it preloaded. I want that to be a little bit bigger, so I'm gonna scoot up. Okay, I've got my calculator preloaded with 4 over 7 as a decimal, so I punched in 4 divided by 7, I hit equals, and I got this decimal. Once I have 4 over 7 as a decimal, I need to somehow do this button. So you can do that button by hitting the second button first. So there's a button right here, second. If I hit that button, then I get access to this sine inverse button. All the trig buttons turn into their inverses. So this used to be sine, cosine, tangent. If I hit second, it turns into sine inverse, cosine inverse, tangent inverse. So I'm going to hit this button. Okay, so I punched in 4/7, made that a decimal, I hit the second button, and then I hit sine inverse. Okay, let me do that quick. 4/7, second sine inverse, I get 34.8499 da 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 da. I'm going to round that off to 2 decimal places. If you need a refresher on rounding or you're not sure what I'm doing when I'm doing that, check out the How to Round to 2 Decimal Places video. It's under both general information and lesson 6.2. But I have 84 and then the next digit is 9, which means I round the 4 up to 5. And this is theta, which is an angle, so our units here are going to be degrees because we're finding an angle. And that's our answer. Okay, so there's the whole problem together. I'm just going to recap it really quick because that was maybe a lot. So we started with our triangle and our missing unknown angle. We figured out which sides we had, so we labeled our triangle opposite, adjacent if needed, hypotenuse, and determined that we had the opposite and we also had the hypotenuse. Those sides were labeled. We used that to figure out that we wanted to use sine to write our equation. And if you need to reference SOHCAHTOA, you can do that. We were looking for which trig ratio involves the opposite and the hypotenuse. Once we figured out we needed sine, we came up to write our equation. So we had sine, theta is unknown, so it stays a variable, equals, and then we did the opposite side over the hypotenuse. Now we're solving for theta, so we need to get rid of sine. We do that by applying the inverse to both sides of the equation. So I did sine inverse on the left, and I did sine inverse on the right. Sine inverse and sine nicely cancel out, so I only have theta left over here. And then I just needed to use my calculator to evaluate this. Punch in 4/7, hit the second button, hit sine inverse. Okay, if you would like to see 2 more examples, there is another video with 2 more examples. Thank you for watching. I hope you liked the lesson.